Welcome to our NLP class. This is part 8. In this class, we are going to see reducing the dimension of the input space, feature space. Reducing feature dimension. So, we have already seen in our earlier classes that how to reduce the size of the input vector. The input vector size would be equal to size of the vocabulary. If the vocabulary is size is v, then input vector would be size of v, x1, x2 up to xv. So, how do we reduce the dimension of this vector? In the earlier classes, we saw that using some pre-processing step by removing stop words, and second one is removing URLs, mail address, and then stemming and lemmatization. Next one is converting into lowercase. So, these pre-processing steps helps to reduce the dimension to some extent. Maybe it might have reduced maybe 40 features or 50 features, but when we compare against the entire feature set like maybe 1000 feature set or 10,000 feature set, this 40 or 50 is nothing. So, when we train our simple logistic regression model, then if we have so many features, then we need to tune so many parameters, theta 1, theta 2 up to theta 10,000. So, this is computationally very expensive, and also it takes very longer time to um, train our model. So, to reduce further, in spite of this pre-processing step, how we can do is we can smartly identify two features. We can specify our feature space as just one, x1 and x2. Only come up with two features. We are going to have our classification model, this f of x. What this f of x is going to do? It's going to predict whether the sentiment is positive or negative. So, here we create two feature. One feature, this x1 is defining the weight of evidence for positive sentiment, and second feature x2 is specifying weight of evidence for the negative sentiment. So, now we have only uh, three features and then two features. This one is the bias term, and two features when we feed all this information into our model, and we need to train only theta 1 comma theta 2. So, we can easily apply our gradient descent algorithm to tune this theta 1 and theta 2. So, now how do we define this x1 and x2? So, we will consider an example, same example, that S1 is I like the movie, the movie was awesome. And second example is I do not like the movie, the movie was boring. So, next step is we need to apply the pre-processing step. In the pre-processing step, the words like I, the, the was, these words would get removed. I do the was, these words will be removed. So our input space becomes S1 equal to the list of the meaningful words like movie, movie, awesome. And then second sentence will have this, not like movie, movie, boring. So next what we are going to do is, we'll see, look at that frequency count with respect to positive sentence and negative sentence. So let us take all the unique words in these two sentences. The unique words are like, movie, awesome, not, bore. It should be bore. After pre-processing, we apply stemming. The stemming creates this word, bore. So now we have our vocabulary, and then we will measure the frequency with respect to the positive sentence and negative sentence. So x1 is, oh, this is not x1, this is just a frequency count. Frequency with respect to positive, this is frequency with respect to negative. We'll see like, how many times like appeared in positive sentence. The first one is positive, this is negative. The like appeared one time in positive and one time in negative. And movie appeared two times in positive, two times in negative. Awesome appeared one time, 0 time. Not appeared 0 time in positive and 1 time in negative. Were 0 time in positive, 1 time in negative. Now we have the frequency count of each vocabulary word in the vocabulary. Next step is how to define the feature x1. So the x1 for the sentence S1, that first sentence S1, we need x1 and x2. So the x1 is actually summation of frequency of all the words given in this sentence. So how many words we have in the first sentence? 4 words. So for those 4 words, just add those frequency. I equal to 1 to 4, add the positive frequency for every word. Similarly, for x2, what do we do x2? For all the words in the negative sentence, how many words are there in the negative sentence? 5. I equal to 1 to 5, frequency in the negative frequency for every word. So when I apply this one formula, what do I get? I get for x1, the first word is like. Like how many times appeared? 1 time. And then second word is movie. How many times movie appeared? 2 times. 2. Third is movie. So we already saw this movie 2 times. Then what is the next word? Awesome, 1 time. So it is, the frequency is 4. My x1 for the first sentence is 4. And again similarly I calculate x2. x2 is just looking at the negative frequency for the same words. It shouldn't be 5 here. We are just looking at we are defining x1, x2 for the first sentence. So we are going to look at only the first sentence. So the number of words would be same, remain same. So what I do for the next one is I to 1 to 4. I just look at the frequency in negative, that negative frequency. For like, how many times like appeared? One time, 1. And how many time movie appeared? 2. And then how many time that awesome appeared? Awesome, awesome, 0. So here the number of words are not 4. I made a mistake. So the number of words are only 3. So we are looking at unique words. It's only 3. So here for the negative sentence, it is only 3. So for my S1, this is my input feature. 1, x1, x2. What is this? 1. My x1 is 4, comma 3. This is very simple, right? Comparing with the Baggerford method or TF, IDF, this is very simple. I do have only 2 features needs to be computed here. And it also conveys the meaning. So the first features represents the weightage towards the positive sentence, and second feature represents the weightage towards the negative sentence. So I know that the first sentence is a positive sentence, it has positive sentiment. So when I look at this feature value, I see 4 has the highest. The x1 is larger than x2, which shows that the weighted evidence for positive sentence is high. And similarly, we just compute the feature space for S2. 1. What is my x1? x1 will be computed by how many unique words? 1, 2, 3 and 4. Here it is 1 to 4. So look at that positive frequency and see how many times not appeared in positive frequency is 0. And then next one is a like, and positive frequency it is 1. And then movie in positive frequency it is 2. Bore in positive frequency is 0. So my x1 is only 3. I will compute x2 similarly. I equal to 1 to 4. I look at word not, or not in negative sentence appeared 1 time, like appeared 1 time, movie appeared 2 times, and then bore appeared 1 time. So what is my value? This is 5. So my second feature for the second observation is S2, which is 1, 3, 5. Now do you see the difference? So for the first input vector, the x1 is higher than x2, but for the second feature, x2 is higher than x1. So x2 has more negative sentiment. So x2 represents the sentiment of negative, and the x1 represents the positive sentiment. So this methodology accurately capture the weight of evidence for positive and negative. Similarly, we can create features for all the words in my vocabulary. Then once I create my vocabulary, the next one is train my model. Already we have seen how to train our model. We'll just recollect what we have seen earlier quickly. So this is my input space, X design matrix, all my feature. So here I see I have m number of observation, that means m number of sample of record training data size, and then I have my x1, x2 for the first record. And similarly, for the second record, I do have, we can move forward and create features like this. XM 2M. So this is my input space to my mapping function f of theta of x. Then I apply my gradient descent algorithm and create this mapping function. So my what is the height that mapping function for logistic regression model? This is the classification model that would classify whether the sentiment is positive or negative. So here my mapping function f of theta of x, do you remember? Can you recollect? This is the classification model. The mapping function is the logistic regression model, which is a sigmoidal function. Whoever is new to this session, just please go back to our previous class lectures and learn about the logistic regression and how it works, how the gradient algorithm works. So this is all about today's class. In our next class, we will see a probabilistic model for NLP problem. So we'll see basics. Before jumping into the model, we would see some basics about the probability and conditional probability and how we can use those conditional probability in our NLP model. So basically, which is called as Bayesian classifier. Wait for our next class. Till then, thank you. Bye.